In this video, we'll do a couple examples of how to calculate the number of combinations. First, let's start with a bit of overview about combinations and permutations, which often go together. Both of these involve picking a number of items from a larger set. The difference is looking at whether or not order matters. In a combination, order does not matter. This would be, for example, if you were picking a pair of students to work together. It doesn't matter if I pick Tommy, then Joe, or Joe, then Tommy. If order does not matter, that's a combination. In a permutation, order does matter. So if I was picking two students to be class president and vice president, the order does matter. If I pick Nicole, then James, Nicole would be president, James vice president. This is different than if I pick James for president and Nicole for vice president. If order matters, it's a permutation. In this video, we're going to focus on combinations. The combinations formula is represented by NCR. Let's start by looking at what those letters represent. N means the number of objects we have to pick from. R is the number of objects that we want to pick. C means that we're using a combination. So again, order does not matter. This formula uses factorials. So before we look more closely at the combination formula, let's look at what factorial means. The symbol for factorial is the exclamation mark. And what the factorial sign means is that we're going to take that number times all the digits below it down to 1. So for example, 6 factorial can be written out as 6 times 5 times 4 times 3 times 2 times 1. You can use your calculator to evaluate that, although as you'll see in our combination formula, this will simplify down. So in our combination factorial, let's fill our combinations formula, let's fill in the numbers. The formula starts with n factorial. N is the total number of objects we have, in this case 10. Then we divide that by r factorial. R is the number of items we are choosing, in this case 3, times, we then need to subtract n minus r. So n minus r means we're going to subtract 10 minus 3. And that is also factorial. So simplifying this down a bit, that gives us 10 factorial divided by 3 factorial, 7 factorial. Now on your calculator, this would get to be large numbers. Your calculator might not be able to handle it. So we're going to simplify it down. Let's write out what 10 factorial is on the top. So 10 factorial was 10 times 9 times 8 times 7, all the way down to times 1. Then on the bottom, I have 3 factorial, 3 times 2 times 1, times 7 factorial. Now the reason I wrote this all out is to think back to reducing fractions. If a number is multiplied on the top and the bottom of the fraction, they would cancel out. This is because, for example, 7 divided by 7 is 1. 6 divided by 6 is 1. 5 divided by 5 is 1. And so on. So you'll notice I cross out a large part of the problem. Furthermore, I could reduce by finding common factors, or if you have it in a shorter form, we can now just multiply. So now, get your calculator. 10 times 9 times 8 would give us 720 on the top. On the bottom, 3 times 2 times 1 is 6. Divide that out. 720 divided by 6 is 120. So this means if I have 10 items and I'm going to choose 3 of them. There's 120 ways I could do that. Let's try a story problem. There are 13 students in class. How many ways can 4 students be chosen as hall monitors? Using our formula, this is 13, choose 4. So putting this into our formula, this would be 13 factorial divided by r factorial, 4 factorial, times 13 minus 4 factorial. So 13 factorial divided by 4 factorial, 9 factorial. So on the top, I wrote out 13 factorial, which was 13 times all the numbers down to 1. Then 4 factorial, 4 times 3 times 2 times 1, times 9 factorial. So again, I'm going to look for my numbers that cancel out. Anywhere there's the same number in the top and the bottom is going to cancel. That cancels all the way up through the 9s. Since I have large numbers, I'm actually going to look for a little bit more. I notice I have 4 times 3. Well, 4 times 3 is 12. So I can cancel out the 4 and the 3 and the 12. Let's see what that leaves us. Gives us 1,430 divided by 2, or a total of 715 combinations.